Okay, we're looking at section 4.2, and there's a few things in 4.2 that we want to learn about. The first part is graphing. How do you graph quadratics that are in vertex form? And how do you graph quadratics that are in intercept form? So we'll look at what each of those forms look like and how we graph them. And then we'll look at how do you rewrite functions into standard form. So what if we're in vertex or intercept form and we want to rewrite them into standard form? So let's start out with vertex form. Okay, vertex form of a quadratic looks like this. Okay, so you have your a value. It looks very similar to another graph we graphed, which was absolute value. Okay, and we graph them the exact same way. If it's in this form, the hk, the h is going to move on my graph left and right. The k is going to move it up and down, just like it did the absolute value graph. So the hk is the vertex. Okay, and that's also the line of symmetry. Okay, so it's what we're going to do is we're going to simply find that vertex, draw our line of symmetry, evaluate two other values of x to get two more points, and reflect those points. So let's do an example here. Okay, so I'll make my XY axis here. Okay, so the first step, what's my vertex? Okay, just remember, just like the absolute value, it's kind of like an opposite here. So in this case, my h is positive 3. My k stays with the same sign, so that's negative 4. So 3, negative 4 is my vertex. Okay, I'm going to draw that line of symmetry right away. Okay, now I just have to find a couple other points, so now I simply make a little table and I choose a couple points to plug in. Okay, so now you're going to want to stay near the line of symmetry to choose some points. Okay, so maybe I try 1 and 2. Plug in 1 and 2 into the equation, see what I get. If I substitute 1 in here, 1 minus 3 is negative 2. Then I have to square it. Negative 2 squared is 4. Half of 4 is 2. 2 minus 4 is negative 2. So be careful with your order of operation. We got to do the parentheses first, then we have to square, then multiply, and then subtract. Okay, try 2. 2 minus 3 is negative 1. Negative 1 squared is 1. Times a half is a half. So a half minus 4 is negative 3.5. Okay. Now if I don't like decimal, I could try a different point maybe. But we'll just stick with that. So 1 is negative 2. And 2 is negative 3.5 right there. Okay. Now I just take those points and reflect them to the other side. 2 away there, 2 away there. 1, 2, 3, 5, negative 2. This point I can reflect over here. So that's 4 and negative 3.5. There it is. Okay, so that's pretty straightforward. What I'd like you to do is try this one. On your own. Just try that graph on your own. Pause the video and then I'll show you the answer. Okay, so you should have gotten something that looks like this. My vertex would be at negative 2, negative 3. Should be right there. Line of symmetry. Try a couple points. So in this case, maybe I try 0 and negative 1. If I substitute negative 1 in there, I'm going to get 1 squared is 1 minus 3 is negative 2. Right there. If I try 0, I'm going to get 0 plus 2 is 2, 2 squared is 4, 4 minus 3 is 1. So I get that. Reflect it over here. There it is. So that's vertex form. It's fairly straightforward to graph those. Now let's look at the next, which is intercept form. Okay, intercept form looks like this. Okay, you've got your a value on the outside. You got x minus p times x minus q. The x-intercepts are at p and q. And that makes sense because if the x-intercept is when y is 0, right? So if I plug in p into here, p minus p is 0, and 0 times anything is 0. Same thing if I plug in q, I get 0. Okay, so those are my x-intercepts. And because a parabola is symmetric, the vertex has to be somewhere in the middle of p and q. Okay, so here's the steps we'll follow to graph these. We're going to identify and graph those intercepts, find the x-coordinate of the vertex, plug it in to find the y-coordinate, and then finally find one more point. Okay, so let's graph one. Okay. Okay, so the first step, find my x-intercepts. So the p in this case, now notice it's opposites again. So p, the other way to think about it is what would make 0 inside of here? Well, that would be 4 and negative 1. So 4, 0 and negative 1, 0 are my x-intercepts. Those are my x-intercepts. Now we have to find where the vertex is. Because a parabola is symmetric, we know this one opens up, so it does something like this. So the vertex is halfway in between 4 and negative 1. So you could do a couple things. You could count backwards and figure out where the middle would be, or you could simply add the p and the q and divide by 2. So if I take 4 plus negative 1, I get 3 divided by 2 is my line of symmetry, which would be 1.5. So at 1.5, that's where my line of symmetry goes through. Okay, so this graph, the vertex is somewhere along that line. To find that vertex, now we have to substitute that in for x. Oops. Okay, so I've got 1.5 minus 4 would be negative 2.5. And then 1.5 plus 1 is 2.5. Multiply those three numbers together, and you're going to get negative 12.5 for my y. So my vertex is at 1.5, negative 12.5. So if I might as well go by ones here, negative 1. It's way down here somewhere. So I could have scaled this by 2s, might have made my life a little easier, but too late now. So that's 1.5, oops, 1.5, negative 12.5. Okay, so my parabola opens up there. We could find one more point, so we can plug something in, maybe in between. So I could try substituting, I could even substitute 0 in if I wanted to. 0 or 1. So make a little table. Let's try 0. If I substitute 0, I get negative 4. 0 plus 1 is 1. I get negative 8. 0 is negative 8. Flip it over to the other side. So I'm 1.5 away, so this would be 3 negative 8. So there's my parabola. Opens up. It looks like that. Okay. Now let's just do one more real quick It might look different, but it's not. Okay. Now this one you would say, well, I'm not sure what form that's in. But this is actually an intercept form, because if I wanted to, I could rewrite it like this. It's the same as 2x minus 0, x plus 4. Same thing, right? Okay, so this is actually an intercept form. So if I was to graph this one, let's make my x and y. My intercepts would be 0, 0, 0, and negative 4. Oops, it's a minus, right? Positive 4, 0. Positive 4, 0. Opposite. So right there and right there. So we know this is a little easier to find out what's in between 0 and 4. It'd have to be 2, right? 2 something. So my vertex is at 2 something. If I plug 2 in there, 2 times 2 is 4. So I get 4, and then 2 minus 4 is negative 2. 4 times negative 2 is negative 8. Barely fits there. So that's my vertex. I can find one more point. So if I substitute 1 in there, I can figure out what 1 is. So that's going to be 2 times 1 minus 4 is negative 3. That's going to be negative 6. Right there. So I've got my graph there. So even though this one doesn't necessarily start looking like it's in intercept form, it actually is. Okay, so that's how we graph functions that are in intercept form. Okay. Final thing in this section talks about what if I have these different forms and I want to put them in standard form. Okay, so this is something you've done before. So let's just start with something like this. And I want to rewrite that so it's in standard form, which is ax squared plus bx plus c. I need to multiply these things together. So you've probably done this before, but we've got 3 things we need to multiply, and it doesn't matter what order we multiply it in. So I can start with this first, these 2, and I can multiply these together first. So I'm going to leave the 2 alone, and I'm going to do the distributive property. So I have to multiply this x by both members of the other thing, and then multiply negative 5 by both parts. Okay, x times x is x squared. X times 4 is 4x. Negative 5 times x is negative 5x. Negative 5 times 4 is negative 20. Okay, so I can now combine like terms. X squared minus 1x minus 20. Finally, distribute, multiply everything by 2. I get 2x squared minus 2x minus 40. So now I've put it in standard form. Okay. What if I start in vertex form? What if I start in vertex form and I want to go into standard form? Now we have to be careful. We have to follow our order of operations. We have to square first. When I square x minus 4, squaring is multiplying by itself. So I could actually rewrite this as 6 x minus 4, another x minus 4, minus 10. So I could multiply these together first, then distribute the 6, and then subtract 10. That's the order here. Okay, so let's multiply these first. X times x, leave the 6 there. X times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is another negative 4x. Negative 4 times negative 4 is positive 16. This minus 10 stays out there because I first have to multiply everything by 6. 6 times 4, so that's 24x. Well, actually, what I should have done first is combine like terms. That would have been easier. Okay, so now we combine like terms, now we can distribute. Would have worked the other way too, but it's easier. So 6 times 8 is 48. 16 times 6 is 96. Okay, so now finally I can subtract the 10 there. Plus 86. Okay, so that's how we take it from both of the different forms we learned to graph today and put them in standard form. So if you really like graphing in standard form, you could go through that process, then graph them in standard form, and you get the same graphs. But vertex form is a little easier to graph and intercept versus these forms anyway, so you'd probably want to leave them in that form. But we do need to know how to rearrange these equations and put them in the different forms. We'll do more examples like this in class, and that's the end of section 4.2.